Make sure that I'm on. Okay. All right, now, let's do number 77. There are 6 chemicals, and you really have to know what's going on in the solution to be able to figure this out. Okay? So we have A through F. Okay? A is going to be sodium bicarbonate. B is going to be ammonium nitrate. Okay. C is going to be potassium chloride. D is going to be sodium carbonate. E is going to be sodium sulfate. And F is going to be ammonium chloride. Is that all on there? Is F on there too, up there?
Yeah.
Ammonium chloride.
Yeah.
F is not on there.
F is not on there.
So you will have to add to it.
Yeah,
Okay.
that's right.
Okay, good. All right, now. There's another something in terms of a table. And that table is going to be, let's see. There's really not much here. The actual charts, I'm looking for a table of KAs. There's really not a lot of good KA tables. There's not a lot of good, there's only one small KA table. I'll give you a table of good KAs. The only thing I see is 19.7, but I don't think any of them are up here. Okay, now, let me explain. Okay, let me explain the chemistry here. Okay, all right. You have 6 compounds. Okay, 6 salts. Yes. Okay. Sodium hydrogen carbonate, otherwise known as what? Sodium bicarbonate. Ammonium nitrate, potassium chloride, sodium carbonate, sodium sulfate, ammonium chloride. Notice that all, in terms of solubility rules, all 1A or group 1 elements, their salts are always soluble. So lithium, sodium, potassium, rubidium, cesium, francium, they're all soluble. All the salts from those elements, right? All the metals, if you have a metal from 1A, that's 1A, 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 okay? Sodium, potassium, rubidium, cesium, francium, those elements that make salts, they're going to all be soluble. Notice also that ammonium salts are always completely soluble. Ammonium chloride, ammonium nitrate. All right? So far, so good? Yes or no? Now, this is the deal. If the salt, how many components does the salt have? How many? How many? I didn't hear you. 2, yeah. A positive and a negative. Matter of fact, let's draw that. This is going to be sodium plus, what's the charge of Bicarbonate, what's the charge of that? It's not up there. It's going to be -1, right? Carbonate is -2, and a +1 there, it's -1, okay? This is going to be ammonium and, right? Yes? Okay. This is going to be potassium plus chlorine. This will be sodium plus carbonate, 2 of these. This will be and this will be okay? Now, how do I want to address this? Think of it this way. Think of some power, when you think of powerful acids in your study of chemistry so far, what are some really strong acids that you can think of off the top of your head? And we've done this. I mean, we've talked about acids. You know, I've told you stories, anecdotal stories about acids. When you think of powerful acids, what acids do you think of? In other words, which ones are going to make acids? These or these? Which ones are going to be the acids? The ones on the right, yeah. So what acid is that going to be? If I add an H to that, what's it going to be? You don't remember your acid nomenclature? 8, it's a ternary acid, no prefix, carbonate, 8 becomes ic, so it's going to be, no, I said no, I said no prefix. Do you know what a prefix is? Raise your hand if you know what a prefix is. Excellent. So no prefix, right? Okay, good. So that'll be carbonic acid, very good. That'll be nitric acid, very good. That'll be binary, so it'll be hydro, and then the suffix is always ic, right? So that'll be hydrochloric. That'll be carbonic, sulfuric, right? You getting it? Hydrochloric, okay, good. So some of the acids here, H2SO4, HCl, H2CO3, HNO3. Are those the 4 acids that you could make there? Yes or no?
Yeah.
Okay, good. Which one of these are strong acids and which are weak acids? I'll circle the strong acids and put a square around the weak acids, okay? Is sulfuric acid strong? If someone asks you, do you want a cup of sulfuric acid, you know what you say? No, thank you. It scares me. It's probably the most common acid that scares me the most. Deathly afraid of it. Should never be in a high school. I don't care what concentration it is. Should never be in high school. There's no need for it. None whatsoever. You want to make alum? Tough. I don't care. Don't do it. Look at a film. Look at YouTube. Dangerous, 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 dangerous. I don't like it. There's only one other acid that's strong that scares me as much as sulfuric acid. It will dissolve the skin off your body. It will dissolve the clothes that you're wearing. It's disgusting. I hate it. You want to ruin a pair of jeans? Go to the lab and work with sulfuric acid. So sulfuric acid is a very strong acid. How about hydrochloric acid? Is that a strong acid? Is it yes or no? Anybody think it's a strong acid? Raise your hand. Anybody think it's a weak acid, raise your hand. Okay. Okay. Good. If you raise your hand just now, stay away from all acids. If you think hydrochloric acid is a weak acid. Did you ever hear of concrete? You ever hear of concrete? Anybody ever work with concrete?
Yes.
Anybody ever lay sidewalks or a patio, concrete? Anybody? What do you use to clean up with? Use something called muriatic acid. Very strong acid. Very powerful. Does anybody know what muriatic acid is? What another name for muriatic acid is? Hydrochloric acid is muriatic acid. Very strong. Doesn't scare me nearly as much as any of the other acids. It's probably the friendliest, powerful acid that there is, if that's possible.
But does it burn you?
It can burn you, it can dissolve you, it can do terrible things to you, but it doesn't bother me as much. Hydrochloric acid is very strong. Very strong. Okay? Very strong. How about carbonic acid? Is it strong, weak, what? Anybody? Has anybody ever heard of cell respiration? You have. You have. Okay, good. Have you ever heard of breathing? Excellent. Have you ever heard of carbon dioxide? Okay, good. What does the cell make? What does the cell make when it undergoes respiration? What is one of the byproducts? I hope not. Might be. That's not what I'm thinking of. What is it? What's the...
CO2.
Yeah, CO2. So when you have respiration going on in the cell, do you have bubbling in the cell? Does it bubble? Do you ever wonder about that? Like the cell's made of cytoplasm and all those sorts of things, and do you have bubbling in the cell? Is that what happens? What is the carbon dioxide? What is it? What does it form? Does it form carbon dioxide? It forms what? Yeah, it forms carbonic acid, and really, it's this relationship, this and this relationship that allows the carbon dioxide to get out. Then when it hits the alveoli, it turns to water and carbon dioxide, right? Isn't carbon dioxide an acid anhydride? So when it gets to the alveoli, it turns to carbon dioxide and water. So you're breathing out carbon dioxide. But there's a relationship between carbon dioxide produced by the cell and carbonic acid. It gets from the cell through the blood to your lungs in the form of carbonic acid and the bicarbonate ion. Do you understand that? You can't understand that? Yes or no? Yes or no? You don't understand that. I'm not asking you to understand how it works. This isn't biology class. I'm simply asking you to understand relative to cell respiration and the production of carbon dioxide, there is a relationship between the bicarbonate ion, carbonic acid, and carbon dioxide. Do you understand that?
Yes.
That relationship is realized at the alveoli in the lungs, and you breathe it out. So let me ask you a question. Knowing that our entire respiratory system is predicated upon carbonic acid, do you think carbonic acid would be a strong acid or a weak acid? Those of you who think carbonic acid is a weak acid, raise your hand. Okay? If you think carbon dioxide is a strong acid, raise your hand. Okay? Yes. When you think of a strong acid, Z-Man, do you think of something that could digest your body?
Probably
Yes.
Yes. When you think of a strong acid, you think of something that could destroy, consume, digest your body.
Yeah.
Why do you think carbonic acid would be a strong acid? Does it hurt you?
No.
No. So why? What your intuition though says that it's a strong acid?
It is like it's dangerous, but it doesn't.
It's dangerous.
Yeah.
Okay. Okay. All right. Fair enough. Carbonic acid is a weak acid.
It's
Okay. Yeah, it's a weak acid. 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 In other words, this carbonic, this bicarbonate, if that were a weak acid, what does that mean? What's an acid? It gives up what? If it's a weak acid, it gives up what? If it's a weak acid, or if it's let's say something's a strong acid, what does it produce a lot of if something's a strong acid? You got to help me out here, guys. I know that it's the end of the day. This is nonverbal class. I understand all of that. But you've got to help me out here. If something's a strong acid, what does it produce a lot of? What makes an acid an acid? Hydrogen ion, right? Okay, good. Let's say that. All right, that's one of the definitions of an acid. Produces a lot of hydrogen ion. Good. Excellent. Okay. So, what is a strong acid going to produce a lot of? Hydrogen ion. Very good. If something's a weak acid, what will it not produce a lot of? So does that have the potential to produce hydrogen ions? Of course it does. Okay? So if that's a weak acid or that's a weak acid, do you think it would be fairly stable then? Right? Yeah, it'd be stable. So it stays, it doesn't want to decompose. It wants to stay like that. Right? Right? Yes or no? It wants to stay that way, doesn't it? Okay. Okay. So you're with me so far? Are you with me so far? So is that a strong acid or a weak acid?
Weak acid.
It's a weak acid. Okay, good. What about this? Is that a strong acid or a weak acid? It's called nitric acid. Is it a strong acid or a weak acid? It's a very strong acid. These two acids make me very nervous. I've seen what they can do. It's not pleasant. Very important in a developed society that wants to produce a lot of different things in terms of manufacturing, but very, very strong. All right, so you got it so far? This is going to take me another 10 minutes, so you've got to hang in there with me. If you get this, you're going to be in a very, very good position. Okay, now, let me do this. What? Yes?
How can you tell if an acid is strong or weak by looking at its formula?
How can you tell? All right, by looking at the formula?
Yeah.
Well, can I hold off on that question? There's a question, how do you know if an acid's going to be strong or weak? By looking at the formula. And there's sort of a way to be able to do it. Okay, but let me hold off on that just for a second, okay? Now, let's say we want to do this. What would I add these two? What's the opposite of a base? What's the opposite of an acid? A base, good. Okay, so what defines a base as being a base? What's one of the main definitions? A base is something that produces what?
Hydroxide.
Hydroxide ion. Okay, good. Let's see what kind of room I have here. Okay, good. I have enough. Let's see. I can actually go like this. Okay, good. Good. All right, so let me put the unique ones here. So I have sodium. I have potassium, sodium, and ammonia. Okay? Those are the hydroxides. Those are the bases. Okay? Now, all right. This is going to be a little confusing to you because we're looking at two different things. All right. Somebody look up the KB. Look up this. Tom, can you do this? Look up this. KB. Okay? The KB for ammonium hydroxide. Look that up. Okay? Look that up. Ammonium hydroxide. The ammonium hydroxide KB. All right, just put in KB ammonium hydroxide. Okay, and get back. Raise your hand when you got that. Okay. All right. So, what's one of the strongest? What's one of the strongest bases? Anybody know? Strong base. Strong base. Very strong base. It's called lye. We talked about this when we did one of our labs. What's lye? Lye. Look up the formula for lye. What's lye? Lye.
Sodium hydroxide and formula.
Sodium hydroxide.
That's lye. Very, very strong base. Very strong. Very corrosive. Sodium hydroxide. Okay? And why would that be a strong base? The reason is because it dissociates completely. It dissociates completely. It does. What about this? Magnesium hydroxide. Is that a strong base?
No.
Why do I know that? I know that because the solubility rules say that doesn't dissolve completely. It doesn't dissolve completely. That's the answer to a part of your question. If something doesn't dissociate completely, Tom, it's not going to be, if I have 1 mole of magnesium hydroxide, right? And I have 1 mole of sodium hydroxide. If I have 1 mole of sodium hydroxide, I'm going to get 1 mole of hydroxide in solution. If I have 1 mole of magnesium hydroxide, I'm not going to have a whole mole of hydroxide in solution because it doesn't dissolve completely. It doesn't. Yes? If I know that hydrochloric acid is going to completely dissociate, I know it's going to be a strong acid. If I know that sulfuric acid is going to completely dissociate, it's going to be a strong acid. If I know that carbonic acid is not going to completely dissociate because I have this, and there's a relationship with the blood, it can't completely dissociate because it would eat you alive if it did. It would eat you alive. In very small amounts, it dissociates. I know that nitric acid is going to completely dissociate. So therefore, I know it's going to be a strong acid. So it has something to do with the dissociation. Now, do I memorize all dissociations? No. There's something called a dissociation constant for acids and bases. Tom's looking the one up for ammonium hydroxide. Have you found it yet for ammonium hydroxide, the KB?
17.8.
What is it?
17.8.
17.8 is the dissociation constant. 1.7 times 10 to the 1.
Yeah.
Is that right? Is that right?
1.78.
What? All right, let me just, okay. All right, hold off on that until the next film and I'll look at that. Okay? All right, now. You know what? I'm going to get rid of this. Okay? Only because I don't want to confuse everybody. I'm going to give you a rule of thumb. I'm going to do that once in a while in acid base because you guys are very young acid base students. Okay. I'm going to backtrack on that. And I'm going to say that that's going to be just NH4 plus. That's all I'm going to say. Okay, I know that these are very, very strong bases. I know that these are strong acids. Okay? Yes? Yes? All right, now. And I'm not going to give you ones that aren't obvious. Aiden, are you with me? I'm ready to start. I just had to give you a little background, okay? Right? I'm going to make this simple in less than a minute now. Now we're ready to begin. All right? Now you know enough to make sense of this, okay? Okay, now. Here is sodium carbonate. Okay? Yes or no? Okay. Is this the salt of a weak base and a strong acid, or the salt of a strong acid and strong base, or the salt of a strong base and a weak acid? Which one is it? It's a salt of a strong base and a weak acid, correct? You get that? So there's a weak acid there, isn't there? Yes or no?
Yes.
You got that? Are you sure you got that? Yes? That means that this will be basic. And I'm going to explain what that means in a moment. Is this, here's your rule of thumb. Anytime you see ammonium as an ion, it's going to be acidic. And I'll explain what that means in a minute. Okay? Ammonium means that that's going to produce an acidic environment. You get that? Okay. Potassium chloride. Which one is it? Is it the salt of a weak acid and strong base, the salt of a weak base and a strong acid, or the salt of a strong acid and strong base? T.
Strong and strong.
Strong and strong. Therefore, it's going to be neutral. It's going to be neutral. What about this one? Carbonate. That's going to be the salt of a strong base and a weak acid, right? Yes?
Yeah.
Okay. What about this one? Both strong, right? And what about this one? That ammonium thing there, right? You get it? You understand? Yes or no? Yes or no? All right, I'm going to show you what a little bit more of what it means. Okay. If I take sodium bicarbonate, if I take that, does it all dissociate, yes or no? Does it all dissociate, yes or no? Does it all dissociate, yes or no? Yes, all sodium, Laura, that's really important. I said it in the beginning of the period. Everybody, all sodium salts completely dissociate. Okay? It's real important. You get that? You get that? Yes or no? Okay. We know, and thank God, carbonic acid is a weak acid. Right? What does that mean, it's a weak acid? It doesn't want to dissociate, right? Okay. that's not going to go very far, is it? Right? So that's very, very low quantities, right? According to that being a weak acid, correct? Yes or no? This, we don't worry about that. But do you understand where this is, this is coming from the water, correct? Do you get that? Okay, I'll explain why that kind of cancels out tomorrow or the next day, okay? But anyway, so do you understand that this doesn't happen much? Does it? What's the definition of a base, of an acid? It gives up, it's a proton, it's a hydrogen, it's a proton what? Starts with a D. What does an acid do? Tell me. What does an acid do? Yes, T. What does an acid do? It does what?
Dissociate.
Well, salts dissociate. What does any acid do? Any acid. What's its characteristic? If I was looking around for an acid, what would I look for? One of the things. Hydrogen ion. Right? Yes or no? Right? So if this was an acid and the cap was the hydrogen ion, right? Right? That's what I would know, right? That's what I'm looking for, the cap, right? Right? This has a cap, it must be an acid. Is it a strong acid? Means does this cap come off easily or difficult if it's a strong acid?
Easy.
It's what comes off what?
Easy.
Very easy. How about if it's a strong acid? It's kind of glued on here, isn't it? Okay? Right? Yes or no? Okay, good. So if an acid is the source, if the acid is a source of protons, what's a base?
Hydroxide.
Well, let's hold off on that for a second. What's a base? Source of what? Yes, T.
Electrons?
No. Yes, but hold off on that definition. We're talking about, in other words, we're talking about a particular theory. That's a base. What's the ingredient? What's the main ingredient for a base? Hydroxide, right? Okay, good. Yes or no? Okay, good. Now, we're inches away. We're inches away from one of the hardest concepts in all of chemistry. Believe it or not, people struggle over this. Struggle. Are you ready? Are you ready? Okay. If I take carbonic acid, there's not a lot. Is there a lot of this in solution or only a little in solution? Is it a little or a lot? If I put carbonic acid into solution, is there a lot of this or not much of this? What's the answer? Is there a little of this or a lot of this?
Little.
It's only a little, right? Yes or no? You get that? And why? Because it doesn't want to give up that hydrogen, right? Right?
Yeah.
It doesn't want to give it up, right? Okay, good. Now, you with me on that?
Yes.
Are you with me?
Yes.
Yes, okay, good. Now, I'm going to take this and put that in solution. Do I get a little or a lot of this? I get a lot, don't I? Because it dissociates 100%, doesn't it? Mr. Excitement, right? It does, right? All right, so get what I'm doing. You ready? Get what I'm doing. This is big. Big. Don't. Blah. I like that. All right, you ready? Big, right? Big. If this doesn't like being it, what does it want? This is all that's in solution now, because this is spectator. Sodium ions, they spectate. They don't. They're not going to do anything. Trust me. They're not going to do anything. Right? What does that want? Does that like being that? Does the bicarbonate ion like being a bicarbonate ion?
No.
No, it doesn't. How do you know? How do you know that does not like being that? How do you know that? They're laughing at me. How do you know bicarbonate doesn't like being bicarbonate? Are you guys losing your mind? I didn't want the computers open.
Oh, I'm not even watching it.
How do you know that does not like being that? How do you know? How do you know? Didn't you tell me that this is a weak acid and that you're not going to get much of that?
Yeah.
Because that's, right?
Okay.
Yes? It's not going to, right?
Yeah.
So does this have a strong attraction for the hydrogen, or does this have a weak attraction for the hydrogen? What, you know what I'm saying?
Alright.
So does this have a strong or a weak attraction for the hydrogen?
Strong.
Strong attraction for the hydrogen.